All right. We are live for day 7 of Avon Code 2024. And today, I have some refactoring to do on yesterday's problem. It took me a while to write the efficient method, and partially because I just wasn't thinking simple enough. So we will try to simplify. Let's pull that problem back up. Um, right, so we had these coordinates. Oh, Alka, thank you, thank you. My birthday will be right at midnight. Um, Right, so day 6, we had a guard traversing a map, hits the walls, obstacles, and turns right. Okay, and for part 2, we have to find infinite loops, which means we have to test placing an object in every place along the original path. Yeah, and see if that turns into a loop. Now, my method for making this efficient enough was basically to see, so my original approach was simulating every step the guard takes. But I changed it so that I would basically look for what's in the guard's line of sight and move the guard directly there. And I would have that indexed by row and column, so that's very easy to find the next piece that's in line of sight. And that's the kind of thing that makes me think, like, oh, I probably should have just stayed with a grid. But no, this is sparse. This is a big sparse data set. So I'm happy with my map and set approach. Okay, so this is that method. Makes guard walk. I return a line and then the guard's new state. I don't think this line was actually necessary. I'm not really using it. So let's factor that out to start. Let's see. We're just gonna do some multi-cursor magic. Okay, so these are the guards to check. Guards, I say. This kind of thing in a pattern match is called a guard as well. So this checks if the guard is on the border facing outside, basically about to leave. In which case we just move the guard outside. I think I can make this an easier check. I could just say case pause. We could just check if moving in that direction puts them outside. So case pause dir if let's see, pause that move dir is outside, not area that contains. Yeah, that works. That works. Then we just return pause that move dir. If it's moving outside, let it move outside. That's our signal. Signal, we're done. Which, I mean, in that case, this can actually just be an option. I avoided doing option at first because I had this tuple thing going on. Let's just do an option. Nope, that's a square bracket. Okay, so this changes even more. So let's say option.when guard would still stay in position. So guard.pause.move guard.dir and area contains that. So when guard or area contains area that contains all of that, the potential next spot Then we do all the rest of the stuff. Okay, all very much cleaner. We take out like 5 lines there. And this, now I split this into, we don't need this case anymore. I split this into north-south and east-west, but I think that can probably be merged into one because that the only real difference is this obstacle vert versus obstacle horizontal, and then the check. So our definition of points in the way depends on it. And well, maybe other stuff matters. But I mean, part of this code exists because of the lines. Let's get rid of the line stuff. We don't need to define a line. Okay, and these two cases can probably be merged. It points in the way is empty. If there's no point in the way, then we just put them on the border, right? You know what? I'm realizing here that in order to check if there's a loop, we don't need a special case where we put them on the edge, on the border. This can be our none case. So there's no new obstacle in the way. So that's when we return none, not when we would exit. I mean, it's basically this case, like we would exit. So I'm going to change this once again. Let me think. If the points in the way is empty. Well, let's redefine it here locally first. So option not when points in a way that non-empty. And then we're going to do this elf case basically, or else case. And that's great because I wasn't really liking this code for putting them on the border. Like you can get what it does, but it's not clear immediately, is it? Yeah, it's not clear. So we don't even have to have that. Oh, already becoming much nicer. Okay, so obstacle. And you know what? That is a bit that depended on our orientation. So we don't have to worry about that anymore. So let's just do the same thing here and see what this is looking like. So option that when points in way is non-empty, or is, yeah, exactly, non-empty. And we can remove that line. Okay, already much nicer. And now the only difference between these two is the points in the way bit. So we can get rid of this guard match. I mean, I guess we could still match to get the points. Yeah. So pause under. Now this handles both cases. And points in a way gets an if. So if dir is north or south, in fact, I'm just going to go to dir and define this vertical. Let's see. Yeah, just define here. Def is vertical. Copilot knows what I want. So if dir that is vertical, then this. I mean, it's still not, I know. We'll see. We'll see. We might have a way to simplify that even further. I think we can probably be clever about this in some way. But for now, we at least do this. And that whole diff is already looking much nicer. Now let's go to where we're using this. So we use it here. And we were doing an iterate. Now we can do an unfold. And since since this returns an option, this kind of self-terminates, right? So we don't have to have this take while anymore, checking if we've actually terminated. So iterator dot unfold, and then we have our initial state. And then, yeah, we take that state, which is just a guard, plug it in here, and we get a new state. Now in unfold, you're supposed to return a tuple of the new state and the thing that you're actually returning. The thing we're actually returning is also the state in this case. So we'll just do it this way. Val next. Let's walk. And then we just do next to next. Ah, Eric Wassel, thank you. Yeah, this is how I dressed going out. I've got my fancy white pants. I just got back and went straight to my computer, pretty much. Oh, no, hold on. This next is an option. So next we're gonna do dot map and guard to GG. Okay, that works, that works. So now this should be kind of a drop-in replacement. Maybe. We just have to fix some errors here. Found an option of guard, required guard. Oh, right. We no longer need this outer check. Okay, great. Drop-in replacement. We've already simplified. Well, you simplified this a lot. Now, the other thing I could do is I could implement part one in terms of this. And that would, well, I mean, part one was kind of nice and self-contained. Parsing this out can be a bit nicer. And then there's stuff I've added to my area and point standard library that I could probably formalize. I should formalize that and test that. Won't have time tonight, but maybe I'll do that as a warm-up some other night. So here, the guard is always going to be vertical. So we just find a case where input is an up arrow. And actually this can be a collect first. Collect the first case. And yeah, that returns an option. The first case of a point that yields that up arrow, and we return a guard with that position and north. Okay, a natural that we're just gonna guess because we know it exists. Okay, cool. Another bit of code deleted. And now I had an extension on grids that allows me just apply the point. So I'm not doing p.y and p.x. I hate doing this because I get x and y mixed up all the time. So let me think. Input. Okay, the problem here is that's a list of string. I think if we turn it to a 2D vector, let's do this. Val grid equals. Yeah, sure, we can use arrays. I avoid using arrays only because they don't print as, oh, wait, that's printing as a, okay, they used to like print as the array's address instead. Row and column. Yeah, that's fair. But I mean, you could, what if you wrote grid call row? You could still mix them up, right? And then you could still mix up the point and be like point, like you're using writing grid row column, and then you write point row column, and then in that case it should be point column row. So grid p. So there should be an apply method. Oh, you know what? Maybe we're not importing the extension method. We'll just import everything from there. I don't know. Maybe I haven't defined it. Let me check. Extension. Oh, yeah, it's here inside of a point. Extension grid. Apply. Oh, I mean, it works on index seek a string as well. So, I mean, if you just do input.toVector, why is that not weird? Okay. So input, we could do input dot to vector, and then we apply, let's apply point 0, 0. Oh, I mean, I don't know why it wasn't working, or why I thought it wasn't working. Okay, so we're just gonna make our input and get to d2 vector here. Okay, and if input, and then we just do the point equals that, and we yield p. Excellent, and we can do the same thing here. Input, apply to the point. There, and now like the grid looks like a map. Why is the card at 0, 0 north? Oh, wait. Collect first case P if input P is north. And in that case, return this. Okay. Cool, cool. I don't love this code. I can make that more clear. Oh, I didn't like my isLoop method either. But we are at the 3-minute mark. There's my alarm. Okay, so I'll commit this for now and maybe clean up a little bit more again later. We can remove this, not using that. Okay. This is day 6. In fact, let's do this. Oh, whoops. We're gonna commit. I forgot my key binding for making this full screen. Okay, we're gonna commit it bit by bit so we see what we changed. Uh, yeah. Oh, look at that. We removed all of that and replaced it with this. So much nicer. And remove that. Iterate and fold is nice. Cool. Clean up 2024 day 6. And it is time. In 50 seconds. I get that. Your brain likes it more. X, Y, M, N, I, J, recall. Oh, let's open up day 7. And I don't know if we're about to go see input 24, 7, sleep 10 seconds. Okay, I don't have to think about that. Here we go. Good luck, everyone. Oh, thank you. Thank you. All right. Oh, let's click into that. And here we go. Okay. We have lists of numbers with some numeric key. Yes, yes, it's my birthday. As of 1 minute ago, a few seconds ago. So, at the end, determine which equations could possibly true. So, and what is our total calibration result? Someone stole all the operators. Oh, do we have to figure out how? So like 10 times 19 is 190? Okay. Each line is a single equation, left to right. Not according to precedence rules. No precedence rules. Okay. And there's add and multiply. Okay. So it's like 2 to the n for each of these. We could just test 2 to the n combinations. F. It's looking like none of these are too long. I mean, we could just brute force it, right? It's day 7. We can brute force it. Only 3 of the above equations can be made true by inserting operators. Okay. What is the sum of the test values from just the equations could possibly be true? Okay. Val possible equations. Okay, so input dot collect. So we have, I guess we could say left hand side, colon space, right hand side. And now we do left hand side dot to int, and we pair that with right hand side, and we split not on a comma but on a space, and do a to list. Okay, and this is a map of int to list of int. I guess we just do to map from all of this. Or you know what, we're gonna do map.from above everything. List of int. Oh, we still have to map. So we split that map to int. Whoa. Okay, we have our possible equations. What are these things called? They're not really. Okay, we're calling them equations. Calibration results. Oh, okay. This is long. We're just gonna make the left-hand side long too. I'm gonna replace two int with too long. Mm, yeah, let's just do that. Two int with too long. Not overthink it. Mhm. Okay, and then val test. Uh, oh, let's see. I'll just call it solvable. And then we have an equation, which is, I don't know, let's just call it the left-hand side and the right-hand side. And I don't know what autocomplete is doing there. I guess we could try to divide the left-hand side. And we could do this. I don't want to do this recursively because it's exponential. We could insert. Yeah, my first instinct is to do this recursively, and that's not good. I mean, I guess we could just keep changing the left-hand side. And can we make this tail recursive? And if we can't make it tail recursive, if we're treeing off so much, I'm taking too long on this. Okay, well, we'll match it. No, true. I think we'll just try to make it efficient. Case nil. If it's empty, then that doesn't really work. I don't know. We'll think about that. Oh, Blue, good morning. Good morning. Okay. Hmm. Okay, hold on. Let's just look. Let's just look at this. I want to know what our stack that's going to be. As long as none of them are more than 10, then we should be fine. So equations, that values, that map, and we're going to get the size of these lists. And then we're going to sort and then reverse. Okay, the longest ones are 12. I think that will fit in my stack size. So I won't have a stack overflow. Cool. You don't worry about tail recursion then. Just check both cases. So let's say there is two things, case N1, N2, onto nil. Oh, wait. That autocomplete was probably good. So either well, no, maybe we shouldn't handle it that way. Maybe what we should do is just take the first one and we either subtract it or divide it from the left-hand side. right? If we divide it from the left-hand side, it implies that we're multiplying it by all the rest on the right-hand side. But it's evaluated left to right. So we should be doing this bit right to left. Right, right. So case, and so we're gonna have to reverse all of these. Just gonna note to self there. Okay. So either solvable and LHS divided by n, and that's even if it's perfectly divisible with the rest of the n's, or solvable LHS minus n with the rest of the n's. Yeah. And I'm just gonna put that short circuit case because I think it'll help with our stack size. So, or there's a precondition, LHS mod n equals 0. Okay, that will work. And that should work fine with precedence rules, right? And evaluate before or. Okay. So we get all the ones that are solvable. Let's see if we can actually do that though. So equations dot, let's count the number that are solvable. Not found. Oh, it's not defined properly. That should be a def. Okay, cool. Oh, I should have been done 5 minutes ago. Whatever. What's our total calibration result? Some of the test values. The test value is the left side. Test values. Okay, the left side is the test values. So we're gonna do equations, and we're gonna not filter with solvable. And then, yeah, take the left-hand side, dot sum. Okay. And here we go. Okay. Equations, that size. I want to check how many we have and how many decided were solvable. And while that's running in the background, or I don't know why it's failing actually. That's from a different problem. Yeah, equations dot size. They're at 848, and we determined only 31 were solvable. That does seem too small. Equations dot count solvable. But glad to know we're not having a Stack Overflow. So let's just do a test here. And open day 07, 2024. Save this as an example so that we can copy paste that in. And we're going to filter the ones that are countable. Okay. Oh, wait, no, we haven't changed it yet. Okay, 190, 10, 19. Oh, are we failing to recurse somewhere? Oh, are we forgetting to reverse? Yes. I'm just gonna do that up here. Reverse. Okay. And now, okay. I even wrote a note, remember to reverse, and I didn't even bother looking at that note. I knew it would happen. I forgot about it anyway. Okay. I gotta have when I write notes to self like that, I gotta write it in a way, like maybe an assert. Um, okay, well that is not the right answer, but it does feel like we're closer. Right, so 354 were determined to be solvable. It's probably something subtle, edge case. And if there's remaining. And in the hand, when there's only one, we just check that they're equal. Now, this should never happen. I'm just gonna turn that to not implemented so it crashes. Because I don't actually know how we want to handle that. Like, identity could be 0 or 1. Let's see. So we were checking left-hand side minus n. I'm just gonna put these in parens, make them explicit. So we try the subtraction, and then we recurse. And we try to divide, but only when it divides evenly. And then we recurse there. And that's if left to right. So that means like we've done all this, and then we might multiply by 27 in the end. Okay, I think it will be helpful for me to work through what one of these cases looks like in the example. Let's go back to the example, and then maybe I'll see where an edge case could get us. So these are the ones that work. 190, 19 times 10. In this case, we first tried subtracting 27. So we have, I'm gonna print my cases here. We'll just do left-hand side and then right-hand side. And I'm gonna do this with an indent. Yeah, just so you know how it's recursing. Okay, let's look at this again. Oh. That's not exactly as helpful. Okay, we're gonna do a hack here. So we first filter those are solvable, and then use that map solvable. Or no, we'll just filter again solvable for each print line. Okay, so we can see each of these cases happening, right? And these correspond to 292. What is that? Okay, so 292, 2016, 611. So We try subtracting 20, and then we try subtracting all the way down. And well, that obviously doesn't work. And then this is where we backtrack and we tried multiplying. And let me think. So in this case, 17. Why does it go down to 17? It should be, oh, I guess 256 divided by 16. Yeah, so 256 was divided by 16. I see. Okay, so in this case, this corresponds to 11 plus 6, which is 17, and then times 16 for 256. No, that's off. Okay, 11 times. Let's look at the explanation here. 11 plus 6 times 16. Yeah. 11 plus 6 times 16 is 17 times 16, 256. That feels surprising to me. 17 times 16. I thought it was left to right, not according to precedence. Why am I seeing? Why am I seeing a 256 then? Oh, wait, this is something it backtracked from. I see. Okay. The way I'm printing this isn't very helpful. Yeah. No precedence. Hey, Zombie Cho. Have you finished? Um, I thought I had it for part one, but it doesn't work on, it only works on the example right now. So there's not much code to debug really. So I might be missing something in the problem. So there are add and multiply. Only well, that's oh, I have indeed. The problem happened to work for me. Great, great. I mean, this problem feels easy. It felt easy. It felt super easy to write this. I just recursively subtract from left. Well, we check if subtracting or dividing works, right? Part two was an easy extension. That's good to hear. Oh, I felt like I had it. I felt like I had it 10 minutes ago, but I have a bug. I'm not doing anything fancy anywhere. Am I getting... We're using long, so we're not getting an integer overflow. This is my algorithm right here. Okay, let's create some test cases. So solvable, let's say 10. And let's just try some test cases until we find like something that doesn't work. Or maybe for each of these that we are saying is solvable, we kind of like show the proof. Instead of returning a Boolean here, we could instead return the expression. that would get evaluated. Okay, yeah, so we're gonna do some testing until we find where my bug is. And I will totally welcome backseating here. Um, let's say 5, right? That should work. And let's say we had, I don't know, 2 times 2 plus 6. That should work. 5. We could just generate the full list of things that work. Oh, yeah, let's do that. So let's just do for, we'll do an ABC. A from 1 to 10. Yeah. B from 1 to 10. Oh, Copilot knows what I'm doing. And then if solvable. Okay, I can give Copilot a chance to autocomplete that. Then we yield I guess a tuple. Or we just like yield a list, sure. Or the ABC. Let's just do a print line. Okay, and let's see if each of these makes sense. There are more than I expected. But 118, 119, 119 should not work. Hey, look, we already found something that's messing us up. And 1110. So why are those considered solvable? Okay, so what happens here with 119 and 112? Oh, wait, there's multiplying. So 1 times 1 plus 9, or 1 plus 1 times 9, so that works. 1110 works because you just multiply them all together. Okay, so those are valid. Those are valid. 125, 127, that works. You add them, multiply, then add. And this is add, then multiply. Or, yeah, add, then multiply. Keep in mind here, solvable works in a different direction. So it does right to left, so I have to reverse everything beforehand. So it has to work from the right, where we take 3 times 3 plus 1, 8 times, or 8 plus 1 plus 1. So 8 plus 2 times 1, yada yada. 5, 4. I suppose I should have done just A and B to start. Let's do A and B to start. That might be easier to check. Okay, how are the ways we can get 10? I mean, okay, so this works. Most of these are adding, and then there's that multiply here. Multiply, so we have 110, 25. Okay, let's try ABC, but only going up to like 6. Where is my bug? So do all of those 2 plus 1 times 2, 3. And we could also have the other problem. We could be failing to find something solvable that actually is solvable. So maybe if we had like an alternative solution to compare this with. Um, yeah, let's do that. So let's have an alternative solution, def solvable tube, and we have a left-hand side, which is a long, and a right-hand side, which is a tuple of 3 ints, or long, long, long. So these are going to be my debug strategies. First, I'm going to just do an alternative implementation of this, and I'm going to enumerate the cases by myself. And then we'll see if that matches up with our solvable method here. And then if that doesn't reveal anything, we could also try, what was the thing about earlier? Instead of returning a Boolean, we return like an expression so that we can investigate. Yeah, like it's an option of the string that gets generated or something like that. Okay, so solvable tube. And yeah, so let's match just get ABC. And we try either C plus B plus A equals left-hand side, right? C times B times A, and then there are just a couple more to enumerate. So this is an or. Okay, we just enumerate those. And we'll compare them. So let's get, oops. I don't know. Let's assign this to foo. And we're just going to yield these tuples. And we'll just have a bar for the other side. And this is solvable tube, where you pass in that tube. And then foo dot same elements as bar. Is that true? Great. Okay. Now this can help us find our bad edge cases. So I don't know. I trust bar is more accurate. Let's look at the size. Bar dot size and foo dot size. And we can do bar dot diff foo. See what bar has that foo doesn't. So bar 78, foo has one extra. Oh, foo has one extra. Let's do foo.diff bar. Foo.diff bar. Hold up. What's going on here? Why are there so many? Oh, okay. It's not just. All right. Let's make these both sets. Set that from. Okay. So let's take the union, see what they have in common. Foo.union bar. And then, or no, not the union. So we'll take the intersect. And I want to see like the size of that too. So bar is probably more accurate, right? So bar.diff foo. And for good measure, we'll do foo.diff bar. So these are the ones that we missed. And these are the ones that are extra. Missed. Extra. Okay. So 2, 3, 4. How does that make 10? 4. Oh, it's like the order. Temper Alex rated with 4 viewers. Welcome, welcome. Hmm. So we are in a debugging session for part 1. My solution is quite simple, actually. It's just my solution is basically these 2 lines of code. And I've been debugging it for longer than I should have. I think I got this 25 minutes ago is when I wrote the solution and tried to run it. It works in the example, but not on the real input. So I wrote an alternative implementation where I just hand list all the cases, and I'm comparing that with my more general solution that handles any number. On like a limited case of just a 3 tuple here, a triple. So foo is my original method. So here's the intersections. They have 74 in common, and these are the ones that we missed. 2, 3, 4. Oh, hold on. We need parens here. That's part of the reason. So if we evaluate left to right, maybe I'm misunderstanding evaluate left to right. Sometimes with these, I kind of just wish we had normal operator precedence because I can do that. Okay, 292. 11 plus 6 times 16. So the parens go left. And this actually means, well, okay, so the parens actually go, my original implementation has the parens actually go right, which is why I reverse everything. So in this case, this is how I reversed it. CBA. Yeah, we reverse it and check if those parens. I have to think. We want solvable tube. Let's make this ABC. Make it a little bit less confusing. And what we want to do is a right to left approach because we're testing a right to left approach. So we're going to write the parens in there. Oh, okay. And now when I do that, they do have the same elements. So maybe this is fundamentally flawed. So when we take this off of the right, so 11, 6, 16, 20, I reverse it. I'm taking from the right. And I try subtracting 20 from there. Is that the same as having parens here, right? Yeah. So this is the least nested. So instead of having, all of these parens nesting to the left plus 20, we can move this minus 20 out to the left-hand side, right? And that's what I'm doing here. Left-hand side minus the right end. And then the right-hand side just becomes the remaining 16, 6, 11 in that reverse order. And similarly, for the dividing, which is what's going to be the next step, we take left-hand side, divide by n, and then the right-hand side is going to be the 6 and 11. Okay, this is fine. This is fine. Is it possible I'm having a parse issue? Right, like this is still working for the example input. And so it's able to handle stuff like this. It has two possible configurations. And 190. Okay. And I didn't find any differences when I tried to do this. Mm. Okay, so I have two avenues here to debugging this. One is to change this to Boolean. And instead of returning a Boolean, we return like the whole expression so that we could then reevaluate it or, inspect or whatnot. Yeah. And then our approach number two, what is our approach number two? Do we have another thing we could do? What other issues can I have that don't have? So let's suppose that my solvable implementation here is correct, which seems to be with all the tests I'm doing. Where else could the bug be? So we are parsing these to too long. So this is not like an integer overflow issue. Hash map. I'm parsing this into a map. Maps have to have unique keys. This is not necessarily going to be unique. Oh my god. Why did I turn this into a map? I found my bug. I think I found my bug. Okay. So I spent too long trying to debug a thing which is correct and not thinking about where else it could be. I'm so confident that that's my issue. I'm going to delete all of this. Other stuff. Okay, and this, why is this a map? It's a list of tuples. Okay, no more map from. Alka, thank you for the raid. So, you're coming in on me as I figured out what my bug was. I spent the last 30 minutes trying to debug my algorithm, which was fine. I was doing all sorts of testing and like really hitting my head, saying, like not knowing what was wrong with it. And I'm pretty sure the issue was that my list here, I was using a hash map, and hash map has to have unique keys. So I was dropping some elements. I was dropping some equations. Wait, what's the issue now? I'll use a non-member of list. Yeah, we don't need this line here. Okay, and yeah, this is a distinct answer. This is it right here. Ah, insidious. I know, like I saw this thing in the input and my brain just said, this is a map. This is a dictionary. So I put them in a dictionary and there's somewhere in there's a duplicate. And I spent half an hour because of that. Okay, but I still have to do part two. Let's see if we can get a good delta. The engineers seem concerned. Just then there's a third operator. The concatenation operator combines the digits from its left and right side into a single number. Okay, so now we have to figure out how to reverse that to make it work with our approach. Because I know our original approach relies on doing the inverse operations. Does this have a clear inverse? 15, 6, 156. 6 times 8 concatenate 6. Let's think more simply. So let's say we have, okay, let's say we have 20, and that's like 12 onto 8. Oh, no. That doesn't work. 28, I guess, is 2, and then 8. So that's like 2 times 10 plus 8. But it's not always going to be 2 times 10. It could be like, I don't know, let's say like this case, it's 2 times 200. And to take from the right-hand side and put on the left-hand side just means, oh, okay, we've got this. Just means we check if the right-hand side ends in this, and we can divide by that. So let's want to check first. If the left-hand side, the last few digits, we could also do this with a mod. Let's do it this way. So left-hand side dot toString that ends with n dot toString. Then in that case, we do left-hand side. We can divide it by some multiple of 10, but we're just going to do it purely in string format. So I know we have this condition here. Let's turn this into else ifs. No, because we want to do multiple. Okay, so we have this, and then we have an and solvable. This is where we recurse, and we take left-hand side dot toString, and we're gonna take some number of digits, or let's drop right, drop on the right, and dot toString dot length, and then turn that back into a long. Okay. So ans2 is just going to be, well, this is now ans2. Number format expression. Oh, we had an empty string. Okay, let's add another case here. The left-hand side needs to be larger. LHS is greater than n. Yeah. Okay. Very simple change. Oh, hold on. Okay, easy peasy. Oh. I mean, we can clean up. We can clean this up a little bit. This line's a little bit too long. Oh, what lesson did we learn here? Right, like I was convinced this is correct. I know. So be careful. Be careful using maps. Make sure your assumption that the left-hand side is unique. Or like, don't use maps until you need them, right? Like I wasn't trying to get any performance out of that. It's still insidious because like I see this colon and I just think dictionary. So like I automatically write that. But I did spend like 30 minutes debugging this, even though it was correct. So I could have found confidence in that sooner. What gave me confidence that it was correct was just trying a simpler implementation against it. I maybe should have done that sooner. I don't know. I don't know. I think I just spent too long continuing to bash my head in that and failing to like take a step back and look where else the bug might be, which it was in my parsing. No, and thanks to check the parsing. Oh, thank you for the wishes. Um, let's see. Let me just check the leaderboards real quick. Not that leaderboard. My ranks. Hey, you know what? I actually made time on part two. That's good. My delta was nice. I think I was happy with that. It was a 5 minute delta. And whose leaderboard is this? Let's see what I'm doing. I should be dropping. Yeah, over the last few days, I'm definitely dropping. Um, so this plugin I use, it has this new overview tab. I mean, a lot of you use it, so you probably already know. But I finally like looked at it long enough to understand what it means. And it's like you get stars you get points for your position per day in the delta list. So today I would have gotten 32 points for that out of a total possible 40, I guess. 17, 16. Yeah, I'm 16th overall, but I guess I'm like ninth on deltas. And you know what I want? Let's just do a little bit of what ifs. If I'd written list instead of map, I'd be right about here, right around the 10-minute mark. Man, it's crazy how long I can spend. Like, do any of you have that? Like, how long you can spend on a little thing tripping you up from something that otherwise goes really smoothly. Like the days when I've been sub 1000, it's just been, I know, no silly mistakes. So that's a trick, or that's the goal, is to figure out how to avoid the little silly mistakes. Let's see, do I have energy to continue? I was doing a refactor of day 6. Um, it's a bit shorter. I'm happy with where it's turning. I was considering implementing part 1 in terms of part 2. So this here just returns like every time the guard hits, the list of times the guard hits an obstacle. Or I use it to generate that list rather. Path. What is this? Mid guard walk. Oh, this is just for part 1. I'm gonna move this part 1 stuff up here. Just so it's not confusing me. Is loop tortoise and the hare. I don't know that I really want to refactor that. I think I've had enough tonight. So let's my tone of rate. I'm feeling kind of snacky whenever I go out to a bar and dance. Oh, let's meet that. Yeah, whenever I go to a bar and go out dancing and come back home, I want to like eat something salty. It's like all that sweating, I guess, electrolytes. But found a fun live band and had some good dancing. Who's still on? Feigned interest, Rascal 2. Oh, you know what, Rascal 2? I've never rated Rascal 2, but I see them around on leaderboards. Let's say hi. Okay. Let's see where they are. I can't tell if they've solved art yet, but let's raid anyway. All right. Well, GG everyone. Thanks for stopping by. Alka, thanks for a raid. Blue, good luck with the rest of your morning. Zombie Cho, GG. Temper Alex, thank you for the raid. And good job, everyone. We'll see you tomorrow.